1 was working drawings in theory, and module 2 is threaded fasteners. So the same thing is covered in the lab. So this is actually the first exercise in that threaded fasteners, or you can say screw threads. Now in this exercise, I hope you can see the exercise in the lab manual. Now here we have two exercises, 2.1 and 2.2. So first we'll go to 2.2 first. I'll show you what is this 2.2, and then we'll come back to 2.1. Now what we are doing is here we are representing the external and internal thread. You know already thread, screw thread, something like threaded fasteners, which is discussed. I think we will be discussing this again in the theory as well. I just want to show you that. Now here, let's just talk about this one. You know this is a general thread, a screw thread, having an external thread and an internal thread. So here if you see this, this is an external thread, which is the threads are outside the cylindrical body. Usually you'll find in screws, bolts, and this is another internal thread, which is inside the nut, or sometimes you'll find it in a blind hole. For example, if you want to fix something to the wall, you usually drill it. You drill it, and then you need to have threads inside. If you want to fix a screw to the wall with something, then you need to have threads inside. So that is called internal thread. So here we are going to draw this one. We are going to represent the external and internal thread. Now if you see the exercise 2.2, here let's slightly zoom out, zoom in. Now if you see this here, this is A. What you see, A is an external thread, and the B, the is an internal thread. So this is an external thread, and B is an internal thread. Now actually we are representing like this. Now in detail drawing, usually how you see a thread, like a thread is something like this, looks something like this. Yeah. Now this is actually the detailed representation how we are going to draw in real. It is something like this. These are the threads. This is an external thread, and this is an internal thread. But usually it is very difficult to draw. For example, if I want to draw in AutoCAD, I want to draw exactly the same. So it takes time for me, it takes angles, and it is really complicated. So we cannot draw easily. You can draw it, but to represent, that is difficult. So what we do is we represent this detail in a schematic way. That is exercise number 2.2. If you read the question here in 2.2, you see the question: redraw the following schematic representation of the internal and external thread. Now schematic means any easy representation. We cannot draw like this, so what we are going to do, we are going to make it simple like this. So this is external thread and internal thread. So if you see the exercise 2.2, the representation will be like this. We are not going to draw the threads which looks like this. We are going to draw like this. Now here we have some dimensions given, how we are going to draw. Diameter is given, thread angle, thread length is given, and the pitch is given. So before we go to the exercise, we should know what is diameter, what is thread length, what is pitch. I think in chapter 2, I think you started with theory, I don't know, but in chapter 2 this week, I think, or no, I think last week we started with chapter 2, where we defined the terms of the screw thread like major diameter, minor diameter, pitch, lead, thread angle. These definitions we learned it. I just try to revise it again. Let me just open that slide for you. me just show the thread. Now here, for example, let me just take this picture. Just want to take this picture. Now here, for example, let me just show you. Now, we already discussed about the major diameter and minor diameter. What is major diameter? This is called major diameter, which is the largest diameter on the screw thread, which is usually represented by capital D. This is all I think discussed in the theory. So when you have threads like this, there are 2 points of the threads. This is the topmost point on the thread, which is called crest, and we have bottommost point is called as root. So whatever it is touching, the crest, okay, the size is a major diameter, and whatever is touching the roots, this one is called minor diameter. Here, if you see, this is the minor diameter. This is the smallest diameter, and this one we represent by a letter small d. Small d. Capital D is major diameter, small d is minor diameter. Now here, thread length. What is thread length? In the question we have given thread length. Means this is the total length of the thread. This is the total length from here to here is the total length of the screw thread. Thread length means the start and end of the thread. Yani from here to here we called as thread length. You can write TL. I'll just write TL because it is thread length. Start and end of the thread. Now what is pitch? Pitch is actually the distance between the corresponding 2 points on the screw thread. It is actually, when we define the pitch, it is actually distance measured parallel to the axis between two corresponding points here and here, like this, between two corresponding points on the screw thread. Now in the question, the dimension means here diameter is actually the major diameter. Whenever we learn or draw any screw threads, only the major diameter will be given. Major diameter will be given to you. So whenever we say major diameter, we generally represent with letter like M10 or M20 or M8. So whatever may be the number, it means this is actually the size of the screw thread, and it means capital D is 10, capital D is 20, capital D is 8, capital D is 14. So this is actually the major diameter, but it is represented by like letter M for the size, designation. So here in the question, the major diameter is given 34, means from here to here is 34. Thread length is given from here to here it is 60, and pitch is the distance between the two corresponding points. Okay. Similarly, for B is for the internal thread actually, and this internal thread, it's like a hole, it's like a box. There is a box. See, SQ51. SQ51 means it's a square box having a hole, and that hole is having internal threads. Because, for example, if I want to fix A, this external thread, into B, so the B should have internal threads. As I told you that external is having threads outside and internal having threads inside. So that's the representation of it. So let us start with the exercise. We'll start with this exercise. We'll start with A and then B. After finishing this, we'll go back to 2.1. So let me just, I hope you can see the screen. Huh? Are you able to see the screen?
Yes, teacher. Please.
No.
Teacher, can you hide the notification down?
Okay, sorry. Okay. Now I will start with the external thread. Now here, the length is not given. Yani the total length is not given. Only the thread length is given. If you see the figure, thread length is given. That is 60. But total length, you can assume it. For example, I want to assume the total length as 100. So I'll try to take a line, some line, okay. And the diameter is 34. So I will just offset 17 up, 17 down. Let me just consider this as a center line. I'll just try to put a center. Now, one idea actually uh, shared by engineer Nikhil is, you in this lab you can form a WhatsApp group if you want. It's not compulsory. It is up to you to just form a group, and then when I'm explaining the exercise, maybe one of you can take the video and share among you yourself in the group. You know, it will be easy. If you want to take a video when I'm explaining the exercise, any one of you can take the video, and then you can share it with you in the same lab. So let me just okay. Now the total length is not given. Well, let us assume 100. So I'll assume 100. Set 100 from here to here. So this is taking this like this. Okay. Now this is my total length, center line. Always remember, center line is must. Any line type scale, whether it is a hidden line or a center line, you must consider that. And whenever there is a cylindrical, any screw thread is a cylindrical body, it's a circular body, so you must represent with the center lines. Now the thread length is given. If you see I'll show you the dimension as well. What I have taken, this is, see, this is 34 because the size is 34, the diameter is 34. The length is 100. That you can take 100, 120, whatever you like, because it is not given. You can assume. I'll take the thread length, which is given 60. So it is from here to here. And this one, I'll just zoom in. This 60 is given. So from here to here is a thread length 60. Then I have pitch. The pitch is 6. So you can see the distance between two corresponding points is 6. So I'll offset 6 for this line. Like this, you can just keep offsetting. This command you already learned in LE2.1-2.2. Now, also I'll try to draw the side view of it. I want to draw a side view. Let me just put a center. Just want to now I'll also draw the side view. There is same diameter D 34. You have the side view as well. Now we have this one. If you see the end of the thread, we have a chamfer here. Always remember, whenever you draw threads, a screw thread, bolt, or any screw, we always have one side chamfer, this one. So we have to do chamfer on one end, but before that, there is, you see, there is small d. You can see capital D, there is a big D, and there is also small d. As I told you, the big D is major diameter, and small d is minor diameter. So how to get this minor diameter? We have a standard rule for minor diameter. Always remember, whenever we draw and when we use a small d, remember, d is we call as a major diameter. You know that. I'll just write it here for your understanding. And whereas small d is nothing but minor diameter. But how to get this? We have a rule. We have a standard rule to get the minor diameter. That is small d is equal to 0.85 d multiply capital D. This is the rule. You must remember this rule. and this is really important. This one, small d, is nothing but 0.85 with the capital D. Whatever the D is given, the big D is given, you just need to multiply with 0.85 D to get the small d. So I'll take the size now. I'll just calculate. You can use the calculator. 0.85 multiply the D, which is 34, which is given in the figure. 34 is a capital D, that is my big D. So I'll get this size 28.9. So 28.9 is another small d. So I'll just make it half because I want to offset from the center line. It will be easy for me to offset. So I'll just offset the center line. This value, offset 14.45, like this. So this is my small d. Okay. Just trim this. Now, if you want, if you can check the size as well. From here to here, you can see this is 28.9. By the formula, small d, which is 0.85 d, we whatever you calculated, you have the same size here. So it is like this. Now we'll do the chamfer, and also we have some thick lines inside the pitch. You see this one? This is actually the representation for the small d. Actually, the lines which you see inside the pitch. Like I'll just zoom in. You see these thick lines. This is actually the representation for the small d. Actually, if you see this, see this is small d. So how to draw? I'll just show you. Now I can do is like I'll just offset. This is 6, so I'll just offset 3, exactly half of it. Offset 3. So I'll just use some other color to make it easy for you. Then what I'll do is just simply trim this, trim like this. I'll remove this. Now, see, I got this. This is actually the small d representation. So now I will just offset the same line 6. So I no need to draw it again. So I'll just offset this. So it will come exactly in the middle. So this is actually the representation for my small d, which is 28.9. After that, I can just remove this line. Do you see this one? This is capital D. Yes.
Can you just repeat the blue line to find it?
Okay. This is actually the representation for small d. So what I did is, you see this one? I simply offset 3 because we have 6. I want a line in between the pitch, right? Exactly. So I offset 3. So I got the line, and then I don't want to draw it again. So I just want to trim this so that I can offset the same line. See this one?
Uh,
This
just
is one.
6 by 2 and put the line, huh?
Yes, this line. Now you can simply offset this blue line for 6, so it will come exactly in the middle there. So offset 6. Now I can just offset this. Select the line and just keep on offsetting. So it will be on the in the middle. Now I can delete this one. Right? I can see this. You can see the dimension as well. This one is the blue line is actually 28.9, and this is actually 34, which is capital D, the big D. Now you got this capital D and small d. We'll do the chamfer here. We'll do the chamfer. I'll remove this one because I want to do chamfer, and at the end I want to use it. So I think last week I did chamfer, and you know how to do the chamfer. So I'll just go for chamfer. Okay, and usually I told you when you do the chamfer you have two methods: distance method, angle method. So I'll go for distance method. So you type D, enter, and but here the distance is not given. So what you can do, just go back. You have small d, You see here. So what you just need to do is chamfer is means 45-degree angle. Always the chamfer angle will be 45. So what you need to do is you just need to connect from small d to capital D at an angle of 45 degrees. So that will be a chamfer. So what I'm going to do, I'm going to draw a line from small d touching the capital D at an angle 45. So 45 means it will show you on the screen. So this is 90, 90 plus 45. How much? 135. That's like this. You can check the angle. This line, between this line, this is 45 degrees. Okay. Just remove this one. Now, what I'll do is I'll just remove this one. Now the same thing you need to do on the other side. If you want, you can do it here with the small d, but I will just mirror this one. So I will just go for mirror. This one. Need to have 2 points in the middle line. This center line will be my mirror line. So I'll select 2 points. Yeah, and enter. So I got the mirror on the other hand. So now I'll connect this from here to here. So after that, you can just simply trim it like this. So you got this chamfer. So your chamfer is ready. And also we'll draw this circle for the small d, which is actually the same projection. You can take it from the chamfer, that is 28.9, that is small d. And you know the size for small d, 28.9. This is for small d. So you got the external thread. Now your thread is ready. And here, this is just a shape here to show that this is, usually this is just a shape to, it means that there is no dimension, that you can assume it, that length, total length is not given. So I'll draw that one. Use 3-point arc. You know 3-point arc. You can go to the arc. You have 3 points usually. So you can select here like this. 1, 2 here, somewhere here in the middle, and 3 here like this. Repeat. 1, 2, 3. 1, 2, and 3 like this. Then you delete this one. And you can just hatch this area. This area. We'll select this pattern 131 always. Select this one like this. Now we have the external thread ready. The same thing. We'll extend the center line because actually we'll use the same center line. Actually, this B should be in the same axis, but we don't have space in the exercise. That's why they put the internal thread, the B, below the external thread. So you can draw exactly, with the same center line. I will draw the internal thread now. The A is finished. We'll go with the B now. The B is actually, this is a box. You have two views, sectional front view and side view of it. So you can see the same thing, but the size is here. You have a square box. There is SQ51. SQ51 means square, and this is 51, this is 51. The length of the box is 60. Now inside this box we have the same threads, the same size, capital D, small d, and this is capital D, small d. And this capital D, the big D and small d will have the same size because you are going to fix the A inside B, so you must have the same size. So I'm going to draw that box first, somewhere here. I don't know the length. I'll take the length. I'll take 60. The total length is given 60 of the box, and the height is how much? You can see SQ15, 51. So this is 51. The height will be 51. So I'll offset 25.5, half of it. I can just easily in this one. Similarly, I can draw the side view as well. This is a side view, that is 51. So I will create the side view here, somewhere here. And this is offset 51, the side view width of the box. So now I have this. You can take the dimension. Now this is 60 and this is square 51. Okay. Now here you can save your time, because here we have the same, capital D and small d is same. So what you can do is I'll take the midpoint here somewhere, and this one I'll say this is my center line. So I'll simply copy this because I have the same thing. So copy from the center. I don't want to draw it again. So copy this one from the center, and I'll put it here because I have the same size. Capital D and small d same. So I'll put it in the box. But here we have the sectional view. The hatching is there. So you see what I'm doing? The same thing I'm projecting here. You can see this. This is capital D because the size will be same, and this is small d. No need for this small d. You can just copy it. So you see this? I just simply taken the capital D. Now you see we have the same what we have drawn in the external thread. The same pattern, the external representation of big D and small d with the pitch. So what I can do, I can just simply copy. I don't want to draw it again. So I'll just copy the same. See, I'll just copy all this. Copy from this point, center point, and I'll put it somewhere here, like this. See, I got one more, so I'll offset one more 6. Like this. The only thing is the hatch. You can hatch it. It's the same pattern 131 always. You can select the pattern. If you want, you can reduce the size as well. Distance between the line, or you can change the angle as well if you want. Just put like this. So you got the hatch. So now your a internal thread is also ready. So you finished with this exercise, that is 2.2. A, that is external thread, and B, internal thread. Okay. Now let's go to the exercise 2.1, and I want you to draw, because 2.1 and 2.2 we have two, but when you draw, when you submit your exercise, try to draw in the same file, and just below this you can draw the exercise 2.1. Like for example, I'll write it here, LE2.1. This is LE2.1. Say this is LE2.2. Okay. Now I'm going to draw this one. Now, what is there in the 2.1? There is a slight change here actually. If you go back to your exercise 2.1, but make sure you put the dimensions when you finish the figure. Always put the dimensions. Okay. Don't forget to put the dimension, because dimensions, they carry marks. So always put the diameter or whatever you have it, like capital D, small d, okay, like this. So you know how to put it. Okay, you can put the dimensions once you finish the exercise. Now I'm talking about 2.1 here. Now what is the change if you see in 2.1? Now this is 2.2. If you go back to 2.1, 2.1 is actually this. If you read the question in 2.1, it says redraw the following, yeah, the simplified representation. Simplified. The 2.2 was schematic representation and 2.1 is simplified, yani the more easy. And in 2.1, this whatever we have drawn just now, it will be, you know, in a simple way, in a more easy way to represent the threads, represent the external and internal. Let me show you that. For example, this is actually the detailed drawing which started with the an explanation. This is made simple in the 2.2, that is this one. We did like this in 2.2. We draw like this lines and we did small lines inside the big lines, that is, you know. And now in 2.1, this exercise is going to be more simple. That is why it is called as simplified representation. So it will be like this now. We are going to draw like this. So no more lines in between capital D and small d. So if you see exercise 2.1, there are no lines inside the, you know, the capital D and small d. So you just need to represent only the capital D and small d with the line. So here is the steps given how we are going to draw the, you know, the thread. You can draw the with capital D, then small d, then you do the chamfer 45 degrees. Step number 4, you take the thread length. Step number 5, it looks like this, and step number 6. So there is one change here. There is one more angle is added here in the 2.1, that is called thread runout. If you see this, I'll just show you. Now the change is everything remains same. This is capital D, this is small d, this is 45 degrees at one end. But here, if you see this one, this is thread runout. Thread runout means here the thread runs out. Runs means ends out here. Starting of the thread here and ending of the thread. So this angle is 30 degrees with the center line. So this is not a chamfer. This you have to draw a line. That line should be 30 degrees, always 30 degrees with the center line. So I'll show you how to do that. This is easy, simple. Just no need to draw all steps. You just need to draw the final figure, that is step number 6, using the same dimensions, because we already did that. So you can use the same dimensions from 2.2 and you can draw in 2.2. So you see this, I'll just copy this here. I'll copy this. So I'll just copy the external thread. Oh, I'll just there's no need for the internal, because internal is not given in the 2.1. So I'll just take the only external one. Okay, I'll copy. I'll put it down here. So now see this one. For 2.1, it is made more simplified way. In simplified means we don't need all these lines. So you will save your time now. So everything remains same. The capital D, this is capital D, that is 34, and this is small d. You already have it. So what you need to do is you just need to connect like this. Take a line. After doing the chamfer at one end, you take a line like this. Now here is the one more angle added, that is thread runout. Let me show you this one. This is called thread runout. If you see that blinking line, this is called thread runout, which is 30 degrees with the center lines. How you're going to draw it? Just say take a line. Okay, simple, from small d, always from small d. Just like I told you, you draw 45 degrees from small d to capital D. Here again, same thing, from small d to capital D, but this line, whatever the line is, should be 30 degrees with the center line. Always, it should be 30 degrees. So how I'm going to do? So this should be 30 means this is 60. This is the 0, this is 90 plus 60. Then I can get the 30 here with the center line. So you can see 90 plus 60, this is 150, 150. So it will be like this. You can check, no problem. We have option to check the dimension, angular. Always see this line with the center line. It should be 30 like this. It doesn't mean that you need to draw an angle 30. No, you must draw a line. That line should be 30 degrees with the center line. Always link the thread run out, always link that thread run out with the center line. So you must, whenever you draw a line, now right now the screw is horizontal. Maybe you are drawing screw vertical in the other direction. So in that case, the thread run out, the angle will change. So always you must consider the thread run out with respect to the center line. So I will draw the same thing on the other side, or you can just simply mirror it. I'll just go for mirror, select this line, enter, and this is center line is my mirror line. So I'll just select 2 points. I got the mirror, so just and this. Okay, that's it. That is the representation for 2.1. Okay, you have the same dimensions. You can put the same dimensions, and we can put the angle as well. This is capital D. Sorry. Just a second, guys. Just give me a second.
يا شباب
هلا
يا اخي كيف اطلع الخط هذا اللي فوق اللي مكتوب فيه له فايل واديت وفيو وانسرت وفورمات؟
يا اخي هو الاوتوكاد حقه موديل 2015.
يا اخي اسهل
أتوقع إنه-
تصير
إيه،
متعلمين
أتوقع
عليه
إنه-
كل شيء.
اتوقع انه يفرق. والله انا محمل 2021 غير مره ترى.
يا شباب الواجب اللي امس كان مجيت عليه 15 درجه من 100 من التوتال كامل.
عندك فرصه اليوم يا حبيبي، لا تستعجل.
طيب اذا انه الواجب الواحد عليه 15 درجه، على كذا كم عليها الاختبارات؟
لا يا شيخي،
مين قال ما يخرج لك؟ قال لك 15 سنه.
ما
Yeah.
ادري.
Okay, guys.
شكله سله.
اللاب برفورمانس عليه 15، اللاب برفورمانس كامل.
اللاب كامل، فانت قسم ال 15 هذه على اللابات الاكسرسايز ولا
Yes, guys. Sorry
Teacher.
about this. Okay. Now we
Teacher.
finished exercise 2.1. So this is what you are going to draw, in your file. So you draw the two exercises, 2.1 and 2.1. One more thing I want to add here. Whenever you finish the drawing, please from now onwards for every lab, use the text. Text, just like I'm typing here. Use the text here. You see the letter A, or you can use text. You can type text on the screen. You just use the text and write your ID like 7, something like this. Okay. Like this. And after finishing your exercise, make sure that you also type your name, ID, and exercise number on the drawing as well, because it will be easy for me when I open the file. It will be easy. And also, the most important thing, when you save your file, whenever you save it, also here you type your ID and then your name and the exercise number, whatever you are going to type. So when you save like this, it will be easy for you to upload in the Blackboard. So make sure that when you upload, before you upload, your file name, should have ID, name, exercise, because it will be easy for the teacher. When I download and open it, when I organize it in my folder, I can see the list of my students. Otherwise, I don't know who has drawn that. So it is difficult to check the name and ID like that. So it is. So I request you guys to please, follow the naming for the file.
We will ان شاء الله teacher.
Okay. So if you have any doubts, please you can ask.
Teacher, I have a question.
Yes.
How to show the line in the app of the program? They show file and edit, view, insert, format.
You mean the menu bar at the top?
Yeah, how to make I don't have it.
Yeah, I'll show you. You usually find this option. You know, when you I can see at the top here, my cursor. I'm going here.
Okay.
Let's see this. You see this one? When you click this one, whenever you see this option, this icon, I'll just try to show this one. Maybe in the screen here. This icon, you know, this icon, this one. You need to click this icon first, okay? So when you click that icon, you have an option here. You see, hide menu bar or show menu bar. Now, right now it is showing me. That's why it is showing hide. So when I click this, it will be gone. I cannot see the menu bar. When I click this again, it says show menu bar. So it shows me, you know, the menu bar.
Okay.
So if you want to see the tools as well, just click this show menu bar, and after that you see this tools options at the top. Now from this tools option, what you can do, go to the toolbars and then AutoCAD, and now you can add whatever, you know, the toolbars you want. Like I want, like for example, you see I remove it,
Modify like this.
tools. See, I am removing it right now. Modify. So now I want to add some toolbar on the left, right, like this. So see tools, toolbars, AutoCAD. See, draw. It will come on the left. Then tools, toolbar, AutoCAD, modify, like this. So like this, you can add the toolbars.
Okay. Thank you.
Okay. Just I'll just take the attendance.